Question number 1. Ice at 0 degrees melts into water. Changing state happen here. Which row of the table gives the changes in mean molecular kinetic energy and mean molecular potential energy? When the temperature remains constant, no change in kinetic energy. When the temperature remains constant, no change in kinetic energy, and when changing state, the molecular forces, intermolecular forces changes. Then solid to liquid, ice melts, solid is converting to liquid, therefore potential energy increases. Potential energy increases, kinetic energy no change. Kinetic energy remains constant when the temperature is constant. Astronomers can use stellar parallax to determine the distance to stars. Which of the following statement is correct? Measurements are made against more distant stars. Actually, the measurements are taken relative to fixed stars. Fixed stars mean distant stars. If distant stars, when the position of the earth changes, their angle doesn't change, parallax angle doesn't change. Therefore, we call it distant stars are called fixed stars. And this is the answer. Yeah, we check the other answers as well. Stellar parallax can only be used for distant star. No, this is used for nearby stars. Therefore, this is wrong. Luminosity of the star must be constant. No, we don't check luminosity here. The parallax effect is greatest for the most distant. No, parallax effect is highest for greatest for shortest distance stars, because we can use this method for nearby stars. The mass of Moon is 0.113. Which of the following is equal to the equivalent mass energy in joule of Moon? Mass is given in U. The mass energy equivalent means E equals delta m c squared. The mass is 0.113 multiplied by 1.66 into 10 to the power of minus 27. You can see the mass of U, atomic mass unit in kilogram. This is the conversion. We multiply by 1.66 into 10 to the power of minus 27. U is converted to kilogram, and then C squared, 3 into 10 to the power of 8 square. Answer C. A mass is oscillating with simple harmonic motion. Which of the following statements about the acceleration of the mass is correct? The acceleration is always in opposite direction to the velocity. This is wrong, because say you consider this is the original length of a spring. This one is moving towards the center. This is the x equals 0, original length, moving towards the center. Moving towards the center means it is moving towards the, acceleration also towards the center. Acceleration is towards the center because force is towards the center. Velocity also in the same direction. Then you can't say velocity is always opposite. Sometimes velocity is opposite to the acceleration. The acceleration is always in the same direction as the velocity. That also wrong. Because sometimes the acceleration moves opposite. Then when it is going away from the center, velocity is down but acceleration up. The acceleration is always from the equilibrium. acceleration is always away from the equilibrium. No, acceleration is always towards the equilibrium point. Acceleration is always towards the equilibrium point. It is the correct answer. It is in the definition, it has acceleration is directed towards the equilibrium point. In the definition, or you can say in the definition, acceleration is always opposite in direction to displacement. Opposite in direction to displacement is correct, but velocity is wrong. Which of the following correctly describes the spontaneous nature of radioactive decay? It is a natural process. No, spontaneous doesn't mean natural. Radioactive decay is random. Random process is different from spontaneous. Radioactivity is actually random process and also a spontaneous process. Spontaneous meaning is different. We cannot influence when the decay will occur. Yeah, this is correct. It cannot be influenced by other physical factors. Then we can't influence that. We cannot predict. Cannot predict means random process. The planet Mercury orbits the Sun elliptical orbit. As a result, the speed of Mercury varies as it orbits the Sun. Which row of the table shows how the speed and gravitational potential energy of Mercury change as Mercury approaches the Sun? Mercury approaches the Sun. When Mercury is approaching the Sun, when the Mercury is close to the Sun, gravitational potential energy is less. When an object is moving away from another object, gravitational potential energy decreases. Gravitational potential energy increases, and when it is totally away from its gravitational field, gravitational potential energy becomes zero. Gravitational potential energy maximum value is 0. When it is at infinity, it has the maximum value. When it is reaching some object, gravitational potential energy increases. Gravitational potential energy increases, I said wrong. Gravitational potential energy increases going away, and when it is infinity, gravitational potential energy is 0. 0 is the highest value. When it is reaching, gravitational potential energy decreases, but value is minus, negative. Negative means less than 0. Yeah. Then here Mercury is coming towards the Sun, gravitational potential energy decreases. Therefore, gravitational potential energy will converge to kinetic energy. Therefore, speed increases. GPE decreases, speed increases. A mass oscillates with simple harmonic motion. The mass has an angular velocity of 2 radians per second and maximum velocity 10 centimeters per second. Which of the following gives the magnitude of the amplitude A of the oscillation in centimeter? We have equation V max, maximum velocity is A omega. Maximum velocity is A omega, then A is equal to V max divided by omega. Then V max is given 10, omega is 2. Easy question. A mixture of helium gas and hydrogen gas is kept at room temperature. Which of the following is correct? The mean kinetic energy of helium molecules is greater than the mean kinetic energy of hydrogen. This is wrong. Kinetic energy of a molecule, any molecule, depends on temperature. When the temperature is different, kinetic energy is different. Here the temperature is same for hydrogen and helium, temperature is same. Therefore, this is wrong. Second one also says that one is greater than the other. Then this is wrong. Then mean square velocity of the helium molecule is greater than mean square velocity of hydrogen molecule. Mean square velocity of helium molecule is greater. Actually, the greater the mass, smaller the kinetic mean square speed, because both have the same kinetic energy, but if you equate them, half into mass of hydrogen into c squared of hydrogen is equal to half into mass helium c squared of helium. When you cancel half to half, and these two are equal, then definitely the mass of helium, we know mass of helium is greater than mass of hydrogen. Therefore, speed of hydrogen, mean speed of hydrogen is greater. If you have a doubt, you can further simplify. C hydrogen squared, C helium squared is equal to mass of helium divided by mass of hydrogen. In front of hydrogen, mass of helium, helium is greater. Mass of helium is greater in the ratio, then speed of mean speed of hydrogen is greater. C squared means mean square speed, mean square velocity. This is mean square velocity. The graph shows how the this graph shows black body radiation curves for two stars. Clearly, when we see the graphs, we can say star Y, the temperature of star Y is less because the total energy is less. When the energy is less, the star Y, the curve is lower than the other one. Then temperature is greater in star X, definitely. Temperature X is greater. This or this, the answer. And from the graph directly we can get, when the graph is above, one graph is above the other one, it has higher temperature. But Wien's displacement law, you can use Wien's displacement law, lambda peak or lambda max. Lambda max t equals a constant. This is the lambda max value for x. This is the lambda max value for y. Lambda max value for x is greater, smaller. Lambda max value for okay, we better say lambda p. Lambda p for x is greater than lambda p lambda p x is less than lambda p y. From the graph you can see wavelength is the x-axis, lambda px is in left hand direction, then lambda px is less than lambda py, therefore frequency x. Frequency is inversely proportional to wavelength, lambda py. lambda px greater than using this equation you can say when the lambda p value less, temperature is high. The lambda p value is less for star x, therefore temperature is high. Temperature is high, Tx is high for Ty and Tx is high for Ty in the C and D both the answers. Then we have to check because the peak intensity of star x is at the lower frequency. Star x is lower frequency, no, low, shorter wavelength but higher frequency. The earth has 10 times the mass of Mars, twice the radius of Mars. The gravitational field strength at the surface of earth is Ge, the gravitational field strength at the surface of Mars is Gm. Which of the following gives the relationship between Ge and Gm? I write the equation for mass. Gravitational field strength of mass is equal to Gm, m mass divided by mass and radius r. Then I write the gravitational field strength of the earth Gm. Mass of the earth is E divided by, so square is coming here. Then we can write the mass of earth in terms of mass of mass. Mass of mass, then 10 times 10 m mass divided by 2 r m squared. Then when we can clearly see that 10 times greater, here is multiplied by 10 times greater and divided by 4 times, 2 squared comes here. 2 rm square means 4 times less, 10 times greater, 2 times less. If you are not sure, you can divide and see, Gm divided by Ge or Ge divided by Gm, all the symbols will be cancelled, you get 2.5. Then Earth's gravitational field strength is 10 times greater and 4 times less. 10 times greater, 4 times less, 2.5 times greater. Then Earth's gravitational field strength is equal to 2.5 times Mars gravitational field.